So a bus covered a distance of 240 kilometers at a uniform speed. Due to heavy rain, its speed gets reduced by 10 kilometers per hour, and as such, it takes 2 hours longer to cover the total distance. Assuming the uniform speed to be x kilometers per hour, form an equation and solve it to evaluate x. Right. So in this particular question, we want to find the value of x, which is basically just the uniform speed. So they've already given us the uh, value of the uniform speed as x. So you can start by saying original speed, right? Because that is the original speed of the car, of the bus, sorry. So original speed is equal to um, x kilometers per hour, right? And we want to cover a distance of 240 kilometers. So remember this thing, a lot of these questions which relate to speed, distance, and time, generally, the distance would be given to us. Um, the speed would be our variable, and we'll try to frame the equation around time, which based, so if I had to check, the formula for time is distance upon speed, right? And I'll try to frame the equation around time because I'll be given the relation between two times, between the original scenario and the modified or the new scenario, right? So let's see how. So the original speed of the bus is given to us as x kilometers per hour. So therefore, the time taken to cover, time taken, right, to cover 240 kilometers, 240 kilometers. So remember, time is distance upon speed will be distance, which is 240, divided by speed, which is x hours, right? Time, distance in kilometers, speed in kilometers per hour, so time would be in hours. Okay. Now, due to heavy rain, its speed gets reduced by 10 kilometers per hour. Okay, so the original speed is x. Now the new speed, there's a new scenario here. The new speed, right? The speed gets reduced by 10 kilometers per hour. So the new speed will be x minus 10 kilometers per hour, right? Reduced, remember the word reduced would translates to a reduction or subtraction rather. And as such, it takes 2 hours longer to cover the total distance, right? So they've given us a relation between the original time and the new time. So let's figure out what the new time will be, right? So therefore, given this new speed x minus 10, the new time, right, the new time taken to cover the same distance, right, will be equal to 240 distance upon speed, which is x minus 10, right? New time taken to cover the speed of to cover at the speed of x minus 10 kilometers per hour. Now, if you see here, it takes the sentence here that tells us it takes 2 hours longer, right? It takes 2 hours longer to cover the total distance, right? 2 hours longer to cover the total distance. So what that means, it takes 2 hours longer, 2 hours longer from the original time, right? So what that means is that the new time is equal to uh, the original time, right? The original time, and 2 hours longer means you add an extra 2 hours to it. So whatever was the original time plus an additional 2 hours will be equal to the new time. That is what this sentence over here means. It takes 2 hours longer to cover the total distance, right? So how do I translate this into an equation? The new time I know is 240 divided by x minus 10, right? The original time is 240 divided by x, 240 divided by x, and to that we add an extra 2, so 2 hours longer, so an extra 2. Okay, we need to solve this equation here. One thing that could help us is to bring all the x terms together, so let's just do that. Let's keep the x terms on one side of the equation. So if I take this over here, I get 240 divided by x minus 10 minus 240 divided by x is equal to 2. Right. Now, to simplify this portion here, the left-hand side of the equation, we'll have to take the LCM, which would entail cross multiplying the denominators like that. So, therefore, what do I get is 240 into x minus 240 into x minus 10. The entire thing divided by x minus 10 into x is equal to 2. Right, so let's simplify this. In the numerator, I have 240x minus 240x minus 240 minus 10 is plus 2400. Entire thing divided by, if I expand this here, the distributive property, x squared minus 10x. All of this equal to 2. So let's try to bring everything in the numerator. It becomes easier to simplify that way. Take the denominator from the left hand side to the right hand side. So therefore, now if you notice 240x minus 240x, so those two terms get cancelled out. I'll be left with only 200 and 2400, which I could potentially divide by this 2 over here. So 2400 upon 2 gives me, or if that step gets a little confusing for you guys, let's do it in the next one. Right, yeah. Give it easier that way. So we have 2400 left here. 2400 is equal to 2 into x squared minus 10x. Right. And now if I'm to divide both the sides by 2, 2400 divided by 2 will give me 1200 and 2 ones are. Okay. So I'm about to get my quadratic equation now. I have 1200 is equal to x squared minus 10x. Rearranging this in the standard form, I have x squared minus 10x minus 1200 is equal to 0. Right, so this here is my equation in the standard form. Now, I have to find two factors of this one. I'll be solving it by splitting the middle term, just like always. So the idea here would be to find two factors such that on multiplication I get my 1200, and on splitting the middle term or on adding the two factors I get minus 10. Right, so let's take some rough workspace here. So the product that we require is minus 1200, yeah, and two numbers multiplied to give me 1200, and when I add them, right, I want minus 10. So the two numbers would be negative 40 into 30, right, because minus 40 into 30 is minus 1200 and minus 40 plus 30 is minus 10. So therefore, what I'll end up with is x squared minus 40x plus 30x minus 1200 is equal to 0. Right, now if I am to factorize the terms, so the first factorization, if you notice, so we have an x which is common, and in the bracket I will be left with x minus 40, right, and between the third and the fourth term, if I take 30 which is common, I'll be left with x minus 40 is equal to 0, right. So as you can see, there's an x minus 40 which is common, so let's write that down, x minus 40, and what will be left in the other bracket is x plus 30, and the product of these two terms is equal to 0. So now we are in a position to use a zero product rule, because x minus 40 into x plus 30 is equal to 0. Therefore I could say x minus 40 is equal to 0, or x plus 30 is equal to 0. Now this gives me, if I just solve the first equation, I get the value of x as 40, or if I solve the second equation, I get the value of x as minus 30. Right, now if you look back and remember what the value, what does x represent, and if you see in this question, it tells us that the uniform speed is x kilometers per hour. Now the uniform speed, the speed can never be negative, right? speed can never be negative. So we'll have to reject this x is equal to minus 30. Therefore, since speed can never be negative, since speed cannot be negative, right, x is equal to minus 30 is rejected, which gives us our final answer. The value of x that they had asked us to find is equal to 40. This is our final answer. Here we did not write a statement because they just asked us to find the value of x. So x is equal to 40 is our final answer.